Welcome to myprojectbazaar.com. Our product title is Unified Power Flow Controller based reactive power dispatch using oppositional grill head. Let us see about the abstract of our product. This proposed design presents an applications of real coded genetic algorithm to obtain optimal steady state performance of electric network, minimizing the power loss in transmission lines and or minimizing the voltage deviations at the load buses by controlling their reactive power are the primary objective of this system. To verify the effective of RGA objective function such as minimization of real power loss and improvement of voltage profile have been studied through standard IEEE test system, and the results have been given. The standard IEEE 57 bus test system is considered to be the test system, and the results are analyzed and compared with existing results. It is observed that the performance of RGA is better in terms of both objective functions, and also this implementation is done in MATLAB environment, and this process only did for the flow basis only, and also corresponding waveform only here we presented, that only we did in this process. Next we see the flow diagram of our product. In this flow diagram here show the IEEE 57 bus system flow. So here mention which one is the conventional power plant and which one is the virtual power plant, that are all given in this flow diagram, and also which buses is connected to which bus, that is given in this flow. Generally, interconnected power systems are complex one day, and there is a need to improve the utilization, reliability, flexibility, and security. Some transmission lines are charged up to the limit load or overloaded, with as an effect on the values of voltage, and in turn reduce the system stability and reliability. For the above reason, there is a necessary to control the real and reactive power flow along the transmission lines to deal transfer of power demands. Transmission network is the most important component in competitive electricity markets and serves as the key mechanism for generators to compute in the supply to reach large users and distribution companies. In competitive electricity markets, energy prices and transmission pricing are highly affected by transmission conditions. The sending end and receiving end voltages are assumed to be fixed. The sending and receiving ends are connected by an equivalent reactance X. By assuming the resistance of high voltage transmission lines as 0, the receiving end is modeled as an infinite bus with a fixed angle of 0 degree. The sending end base angle of a degree, V suffix S and V suffix R are the sending end and receiving end voltages respectively. A small disturbance in the transmission system leads to instability when it is allowed to operate closer to its steady state limit. So certain margin must be left in power transfer, and a small increase of electric power at the receiving end may increase in mechanical power at the sending end, which increases the angle. For the angle above 90 degree, the demand gets increased, which results in less power transfer. This accelerates the generator and further increases the angle. This makes the system complicity unstable. By the IEEE definition, dynamic stability is the ability of the power system to maintain synchronism until small disturbance. Transmission stability is the ability of the power system to maintain synchronism when subjected to a sudden transient disturbance such as a fault or loss of generation. Next we see about the running process of our product. In this proposed implementation is done in MATLAB environment. First open the MATLAB window and open the new M file window, script file. Open the script file. We are writing the program for given objective function and that objective function is formulated by using of given constraints. The constraint is generally classified into two categories. One is equality constraint and another one inequality constraint. For the equality constraint, we find the formulation of the subject variables, and then inequality constraint that set the limits between minimum and maximum of the parameter values. That values is used to help to formulate the objective function of the our objective. So using of that, we find out one value of in the objective function in the number of iterations. So after that, we applying that variable into the genetic algorithm using RGA. So using of RGA, we optimized one best value for the various count of iterations. So here the conversion rate of iteration here, so here the f count is shown, and also best of f of x is shown, and the mean value of f of x is shown, and another one stall of installations of generations is shown in the diagram. So given data are using to draw the variables of output waveforms. So using that, we plot the waveforms. What the parameter is x-axis, what the parameter is y-axis. That is, we writing a command, and that also the derived the waveforms. So first of all, we click the run icon, then the optimize tool window will be open. In the optimize tool window is the genetic algorithm toolboxes. After that, the output waveform is shown. This is the transmission loss convergence for IEEE 118 bus system with facts. The y-axis is transmission loss, x-axis is iteration cycle. Next one is the voltage deviation convergence for IEEE 118 bus system with facts, and the y-axis is voltage deviation, x-axis iteration cycle. Similar to, we find out the without facts and also 57 bus system data. Thank you for watching this video.